my products, okay? Let's say I have some really strong bonds over here, okay? These are really strong and they're really hard to break. That means I'm going to need to have, let's say I have my scale here. Here's my balance. I'm going to need a lot more energy to be able to break those bonds apart, right? But what if I have really weak products formed, okay? They're just not going to give me very much energy. So you can see, ideally, we'd like to have it balanced, but that's not always the case. Sometimes it takes more energy and I get less here. So you can see that sometimes the energy is not balanced, okay? And what if instead I don't have very strong bonds, so I'm able to break them really easily, but the products that are formed give me lots of energy. So you can see I'm gonna not have used as much energy here, but it's gonna have produced more energy, right? So this is why we can get negative and positive numbers, okay, when it comes to that delta H. What else did I want to tell you? Oh, in exothermic reactions, so ones with the energy over here, more energy is released. So this is a picture of an exothermic. More energy is released than is absorbed over here. The other way, if my scale is this way, then more energy was absorbed than released. That's going to be endothermic. So that's just a visual picture of that teeter-totter. So now look at table 13.1. And this is probably the time I'm going to mention this to you guys. If you look back in the Appendix A, in the back of your book, it's on page 565. I would go ahead and print off page 565 and 566, okay? These tables that are in this section, instead of flipping back and forth, because you're going to need them for your test too, go ahead and just print them off. I printed them off, and then I put a little bit of information on there that I want to remember, okay? So the first one I'm going to use is this bond energy table, okay? Now, this tells me how much energy it takes for certain bonds, okay? We're just going to be using the ones on this table. There are more than this, though. Keep that in mind. So if you look, the first chemical bond is a single bond from a carbon to a hydrogen. And they're telling you that it takes 411 kilojoules per mole. So really what that's telling you is if you need to break a carbon to hydrogen bond, single bond, it's going to take that much energy to break it. But in the same manner, if you want to form a carbon to hydrogen bond, it's going to give you 411 kilojoules per mole energy once you form it. So these are both for breaking and for forming, okay? Let's see. Okay, so for bond energies, this is how you're going to do your equation. It's the sum, okay? All of these we're going to be talking about this module are the sums, okay? So for bond energies, we're just going to take the sum of the reactants, and we're going to subtract the sum of the products, okay? So you can see that right here. The sum of the reactants minus the sum of the products, okay? So we're going to get our numbers from our bond energy. So let's take a look at the first example 13.2 for this. It says, to make ammonia, nitrogen, and hydrogen are reacted at high temperatures according to this equation. And then they give you this equation. N2 plus 3H2 gets me 2NH3. So this is the equation they give me. And then they say, what is the delta H, or the enthalpy of this reaction? Is it endothermic or exothermic? So I'm going to keep my bond energies handy, okay? So I need to remember, I'm going to take my reactant side and then I'm going to subtract my product side. So first I need to actually make these into bonds, okay? Now this first process of bond energies is going to seem really just not very exciting. It's going to seem like it takes a long time. You actually have to draw your Lewis structures, but hang with me because you're only really going to do it a little bit because we have a much easier method after this that I'm going to show you that we'll be using more. So we need to draw our Lewis structures. So If you don't remember how to do this, go back and brush up on it. I'm not sure if it was like module 7, something like that. So I've got 2 nitrogens, like this. And I know that nitrogen has 5. So I'm going to go ahead and see. I got 1, 2, 3, 4, 5. I'm not going to go through all this. This is nitrogen, okay? And I don't have a number up front, so I only have 1 of these. So I'm going to put this plus, now I'm going to draw this one. So I'm just going to hold off on the 3 for now. I know I have a hydrogen. So I have a hydrogen to hydrogen bond. Okay, that's the H2. But I've got 3 of them. So I'm going to do that 3 times. Okay, so really the number out front tells you how many times to draw that picture itself. Now I'm going to put my arrow. And now I'm going to ignore the 2 for now. And I'm going to draw NH3. So I've got N, and I've got an H, an H, and an H coming off the side. Now I have to do 2 of them. There's my first one, and then I'm going to do a second one. Okay? So that's what that looks like. Now all I have to do is I have to look at each individual bond, okay? So my delta H, I'm going to go ahead and just erase this for now. Put delta H here. I'm going to do my reactant side first, and then I'm going to subtract my product side. So I look right here and I see, okay, I've got a triple bond nitrogen to a nitrogen. So I look on my bond energies, and I look for my triple bond, and I see that it's 942. So the first thing I do is I have to say how many moles I have of it. I only have 1. So I'm going to say 1 mole times, and then I'm going to put that number. It was 942. 942, and then I have to use my units. It's right underneath it. Kilojoules per mole. Okay, that's the first one. Then I'm going to put my plus. Now I'm going to do this one. I have a hydrogen to hydrogen bond. I find it right here. And I've got 3 of them. 1, 2, 3. So I'm going to do how many I have first. 3 moles of this bond, which is 432 kilojoules per mole. Okay, that's this side. So I'm going to put a minus. Now I'm going to go on to the product side right here. So I'm going to just continue this right here. I've got 2 moles. I've got 1, 2 of them. And I have to look and see how many bonds I have. Okay, so just pay attention. Don't skip this part. I've got a bond here, here, and here. Here, here, and here. And they're all the same. It's all a single bond, N to an H. So I'm going to look for my nitrogen to hydrogen bond on my chart here. I see that it is 386. Okay? Oops. Hold on. I made a mistake. 386. I'm just going to put this in here real quick. Joules per mole. But keep in mind, I made a mistake here. I actually have not 2, but 1, 2, 3, 4, 5, 6. I have 6 moles of them. Okay? So, real quick, before I crunch these numbers, I'm going to just double check my work. Okay? I have 1 of this bond right here. Plus, I have 1, 2, 3 of this bond. Then I'm going to subtract it with my products. And I've got 1, 2, 3, 4, 5, 6 of this bond. Okay? So, I'm just going to erase this for our sake because I don't have room. So now all I do is I crunch each one of these. So right here, I'm going to have 942. I'm going to just notate it on the top, and then I'll crunch it all. I'm going to do the multiplication here, and I get 1296. And then the multiplication here is 2316. Okay. Now I can cancel all my moles. I'm going to add these 2 numbers and then subtract this number. Okay? So if I do that, I'm going to end up with negative 78, and then my unit is just going to be the kilojoule that's left. Okay, so they had asked me 2 questions. They said, what is the delta H for this reaction? The enthalpy is negative 78 kilojoules. That's the change in energy. Now, they also asked, is this endothermic or exothermic? So I look at this, and I can tell by looking at my sign. It is negative, which means the energy is part of the products, which means it's going to be exothermic. It's going to give off heat. Okay? All right. So let's look at, I'm actually going to stop, and I'm going to write out the bond energies for this next one.